Let's look at rule number 4. Rule number 4 is for our vertical asymptotes. We have 2 steps for this rule. Rule number 4. First step, we need to reduce the fraction if possible. Reducing means we need to factor everything and see if anything cancels on top and bottom. You have to do that first or you'll get your vertical asymptotes wrong. So we reduce first, then we set the denominator equal to 0 and solve. So let's try that here with example 4. First step, I need to make sure to reduce first. So factor everything I can and see if anything cancels on top and bottom. In this case, I factored everything and there's nothing on top and bottom that matches that would cancel. So that means I can move on to step 2, where I set my denominators equal to 0 and solve. So in this case, we'll add 3 to both sides. We get an asymptote at positive 3. And we get an asymptote at negative 3. So this means on the graph, we're going to have 2 asymptotes, 2 vertical asymptotes that we draw. One at negative 3 and one at positive 3. Now, very similar to x-intercepts, vertical asymptotes also have multiplicity. And that multiplicity means something, and we'll talk about what it means when we actually get to graphing these. But for now, we do need to get used to finding it. So if this x equals 3, go back to the factor I used to find it, and look at the exponent on that factor. The exponent on this is a secret 1, and 1 is odd, so I'm going to write odd underneath my vertical asymptote. Here, x plus 3 is where I got my negative 3. The exponent on this x plus 3 is a secret 1, which is odd. So I have 2 vertical asymptotes. They are both odd asymptotes for this one. Moving on to B, step 1 is always to reduce if we can. So I look at this and I'm going to factor everything and see if anything cancels out. I already remember from before I cannot factor x squared plus 9, which means nothing on top and bottom matches. I can't cancel anything out. So that means I take my denominator, set it equal to 0, and I very quickly notice, just very similar to when we did the domain, I have square root of a negative. Can't square root a negative, that's imaginary, and we don't have imaginary numbers this chapter. So in this case, there will be no vertical asymptotes, because there's no way we can set the denominator equal to 0. Let's try C. Always got to reduce first. Factor everything and see if anything cancels. So let's factor the denominator, and hey, look at that. Notice that this time I have something that's canceling. I have an x plus 3 on top and an x plus 3 on bottom that cancels. So if I look at what's left, I'm left with a 1 on top and an x minus 3 on bottom. So I reduced first. Now I'm going to set the denominator equal to 0 and solve. And that is the importance of that first step in our rules that we highlighted. That we need to reduce the fraction first, if possible, then set the denominator equal to 0. This thing that we canceled, that we reduced, those 2 x plus 3's, they are actually called a whole. And that is one of our 2 advanced rules that we will learn about in 3.3. But for now, we don't really need to know about wholes. We just need to know we need to cancel them first, then look over here, and that's how I get my vertical asymptote. Now, this vertical asymptote came from x minus 3, which has a secret exponent of 1. 1 is odd. So this will be an odd asymptote. So that is everything you need to know about vertical asymptotes. Reduce first, then set the denominator equal to 0. And that is rule number 4. In the next video, we will talk about our last rule of today, which is horizontal asymptotes.